To my YouTube channel. Today we are going to be taking 10 likely Jamb questions for physics students, for day 2 students. That is to say, we are believing that you are likely to see this question on SAC today, which is tomorrow. Please do well to share this video to your friends writing physics tomorrow. Now, what is the first question on the board? The first question says, the instrument used for viewing above or below obstacle is what? That is, what is the name of the instrument that is used to see above or below the normal level of vision? The answer to this question is a what? A periscope. Take note of that. Now, what is a periscope? A periscope is one of the applications of plane mirror. Remember, plane mirror has various applications, to which periscope happens to be the first application of your what? Plane mirror. And then remember that your periscope consists of two plane mirrors that are parallel to each other. And when that is done, it produces one image. Take note of that. Produces one image. So how many images does this periscope produce? One. Even though the mirrors are parallel, it is usually adjusted so that it produces one image. Okay? Question number 2. The instrument used by fashion designers to produce multiple colors of image is what? The answer to this question is what? Kaleidoscope. Take note of that. Kaleidoscope is a device used by fashion designers to produce multiple colors of image. Now take your book and your pen and jot this down. The angle in a kaleidoscope is 60 degrees. And because it is 60 degrees, you can calculate the number of images formed by a what? Kaleidoscope. By using the formula for determining the number of images formed by inclined mirrors. What is the formula? The formula is given as n equal 360 over theta minus 1. Now, if the angle in a kaleidoscope is 60 degrees, you put 60 here, you have n equal 360 all over 60 minus 1. Remember that 360 over 60 will give us what? 6. And 6 minus this one will give us 5 images. So take note that a kaleidoscope produces what? 5 images. Take note of that. While your periscope produces what? 1 image. The angle between the mirrors in your periscope is either 0 degree or 180 degree. If you put 180 here, you have 360 over 180 to give you 2. 2 minus 1 will give you 1. So a periscope produces 1 image, while kaleidoscope produces what? 5 images. Wow. Question 3. What is the formula for the efficiency of a what? A circuit. This is not the efficiency of a machine. No. This is the efficiency of a circuit. Now you can determine the efficiency of a circuit by using this formula. Formula number A, efficiency is voltage over EMF times 100 over 1. And formula number 2 is efficiency is equals to external resistor all over internal plus external times 100 over 1. This is smaller than R internal resistor. So these two formulas are used to determine the efficiency of a circuit. Question number 4. Resonance in AC circuit is said to occur under what condition? There are several conditions for resonance to occur in an AC circuit. Okay, I think we have to clean this part of the board so we can write out the conditions. Now, conditions for resonance. Conditions for resonance. For resonance in what? In AC circuit. Remember, AC means alternating current. Condition number 1. Capacitive reactance will be equals to inductive reactance. That's condition number 1. And if this is achieved, it means that your voltage across the capacitor can also be equal to your voltage across the what? Inductor. Condition number 2, maximum current is obtained. Take note of that. When maximum current is obtained from a circuit, you know that circuit is in what? Resonance. Number 3, your impedance is minimum. Impedance is minimum. Condition number 4, resonance frequency is obtained. Resonance frequency is obtained. And remember that at resonance frequency F naught, you have 1 over 2 pi square root of 1 over LC. L is known as your inductance. L is your inductance, and inductance is measured in Henry, which is H. C is your capacitance. Your capacitance is measured in farad, which is F. Take note of that. So, conditions for resonance to occur are given below. 1, 2, 3, and 4. Other minor conditions could be that your impedance is equal to your resistance. This is called impedance. Take note of that. Why this is called resistance? Take note of that. Impedance is equal to resistance. That should be condition number 5. Let's quickly rush this question. What are the complementary variables according to Heisenberg uncertainty principle? Remember, Heisenberg told us that it is not possible to measure two complementary variables with certainty of 100%. Now, these complementary variables are 3 in numbers. What are the complementary variables? I am going to give you these complementary variables alongside with a formula that will enable us to demystify question number 6. Now, what are the variables? Number 1, change in momentum times change in velocity is equal to your Planck constant. Number 2, change in velocity times change in position is equal to your Planck constant. Okay, number 3, change in energy times change in time is equal to your word Planck constant. Sorry, I guess this is your change in position. Okay, so change in momentum, change in position is Planck constant. Change in word, velocity, change in position is Planck constant. Change in energy, change in time is Planck constant. Take note of that. Now, question number 6 is if the uncertainty in measurement of position of a particle is this, what is that in momentum? So you are momentum and position. Please, I beg, write down. This one is position. This one is momentum. This one is velocity. While this one is energy. And finally, this one is time. That is what we call the complementary variables. So it's either it is momentum and position, velocity and position, energy and time. Let us use this formula to solve the other question. Let's use this formula to solve the other question. What are the questions? The question number 6 says that if the uncertainty in measurement of position of a particle is this, that is, change in x is worth 5 times 10 raised to power minus 10 meter. What is the uncertainty in word? Momentum. Change in your momentum is unknown. What is our Planck constant? 6.6 times 10 raised to power minus 34 joule seconds. Wow, so interesting. Remember that momentum can pair with position to give us Planck constant. And if we are looking for momentum, it means that change in momentum will be Planck constant over change in what? Position. So what is your Planck constant? Your Planck constant is 6.6 times 10 raised to power minus 34. What is your position? It is 5 times 10 raised to power minus 10. So let's quickly divide this value. Okay, now we are going to do 6.6 divided by 5. First of all, remember your Jamb calculator you can't press this exponential value, so you divide these two first. That will give us 1.32. Then you take 1 of the 10, you minus the power, so you have minus 34. Remember for indices, if you are dividing, you minus, so minus 10. To which minus will give us plus. So 1.32 times 10 raised to the power minus 34 plus 10. So 1.32 times 10 raised to the power minus 24. What will become the units? Remember, momentum is what? Mass times velocity, which will give us what? Kilogram meter per second. This is the answer to the question. Question number 7. The wave theory of light cannot be used to explain what? Remember that wave can behave as a part. Light can behave as a wave and can also behave as a particle. If light is behaving like a wave, it means that the light will exhibit what? The properties of wave. And what are the properties of wave? The properties of wave, or the property that shows that light is a wave, is number 1, reflection. Take your book and your pen, write it down. Number 2, refraction. Number 3, diffraction. Number 4, interference. Number 5, polarization. These are the properties of wave. So the evidence that shows that light is a wave is the fact that light can exhibit this property. Now, what are the evidence that shows that light is a particle? Now, if light happens to be a particle, it means that it will have particle what? Property. And what are the particle property? The particle property of light is number 1, photoelectric effect. Particle property of light is photoelectricity or photoelectric effect or photoelectric emission. They are all the same. 2, thermionic emission. 3, Compton effects. 4, emission and absorption. etc. So, when we talk about the wave particle duality, for wave we have this, for particle we have this. So the question says the wave theory of light cannot be used to explain what? The wave theory of light explains properties of wave and not particles property. And the particle property here is what? A. This is our answer. It is particle property, not wave property. For wave property you have this. Particle property you have this. So they are talking about wave and not particle. So we have 3 more questions to go before we call it a day. Thank you. Okay, question number 8. A photon have a wavelength of this, behave like a particle of a certain mass. The value of the mass is what? Wow. A photon have a wavelength of this, behave like a particle of certain mass. The value of the mass is what? Okay, let's quickly solve this question. Now, let's quickly solve this question. This question is gotten from the solution to question number 8. Do you remember the de Broglie's wavelength? The de Broglie's wavelength. Remember, the wavelength is giving us Planck constant over momentum. And remember that momentum is mass times velocity. So we have our Planck constant over mass times velocity. Wow. So we are not working with momentum because it was not given here. We work with the other formula. The other formula we are working with is this and this. So let's bring it together. Wavelength is Planck constant over mass times velocity. Okay, remember our Planck constant, you're supposed to know it by now, 6.6 times 10 raised to the power minus 34. And that your speed is the speed of photon, speed of light, 3 times 10 raised to the power of 8 meters per second. So our variables are complete. Now what is the wavelength? See it. 6 times 10 raised to the power minus 7 equals to Planck constant, see I'm here, 6.6 times 10 raised to the power minus 34. All over, we are looking for the mass. Some of the time, we ask to calculate for the de Broglie's wavelength. Sometimes you'll be told to calculate for the mass. So you have mass times velocity 3 times 10 raised to the power of what? 8. So what do you have? 6 times 10 raised to the power minus 7 equals to 6.6 times 10 raised to the power minus 34 all over 3 times 10 raised to the power of 8 times what? N. I guess we have to cross multiply here. Let's cut this thing short. Remember, I'm looking for mass. So I can take my mass here and bring this guy here. Cut it short that way. So you have mass equals to 6.6 times 10 raised to the power minus 34 all over. Take your mass here, bring this one here. So you have 3 times 10 raised to the power 8 times this one. 6 times 10 raised to the power minus 7. So let's quickly do that. We have 6.6 times 10 raised to the power minus 34. If we multiply this by this, we have 18. Combine these two, you have 8 plus minus 7. That will give us 10 raised to the power of what? 1. See, 8 minus 7 is 1. So you have 6.6 times 10 raised to the power minus 34 over 180. I've told you before, use this to divide this with your calculator. You cannot press this in your Jamb calculator. Let's do that quickly. 6.6 divided by 180. That will give us 0.037. 0.037 times 10 raised to the power minus 34. So let's convert it to standard form properly. You have to move your point from here to here, and that is 2 times 1, 2. So you have 3.7 times 10 raised to the power. If you remove 2 from here, you have minus 36 meter. Kilogram. This is the mass of the word photon. Now, let's take the other question. Calculate the energy of the third level if the ground state energy is minus 24.8 eV. EV means your electron volt. Can I clean off the board so that we have a space to solve this question? Okay, let's do this quickly. Calculate the energy of the third. The third means that N is equals to 3. This is solution to number what? 9. The ground state, meaning the energy of the atom in the ground state, is minus 24.8 electron volt. What is the energy of the third level? Now, what's the formula for the energy of any level of the atom? Is equal to the ground state energy over N squared. N is referred to as the number of the energy levels of the atom. So we are looking for the energy level of 3, okay? Oh, you have N. So for any level of 3, you have E3 is equals to ground state. What's ground state? Minus 24.8 eV. All over the number, which is what? 3 squared. So that will give us minus 24.8 eV over 9. Let's quickly divide this with our calculator. 24.8 divided by 9. 2.8. So the energy of the third level is 2.8 eV. Okay? This is the answer to your question. Remember that 1 eV is 1.6 times 10 raised to the power minus 19 joule. So if you want to convert it to joule, use this one to times this one. That will become your answer. Okay, let's take the last question. The last question says that the energy of a photon having a wavelength of 10 raised to the power of minus 10 meter is what? What is the energy of a photon? Energy of a photon. What's the energy? Energy is equals to HF. And remember that F is equals to V over lambda. Therefore, energy will be HV over lambda. Wow, that's interesting. So if I'm looking for the energy, I will do energy 6.6 times 10 raised to the power minus 34. Remember that V is the speed of light and it's constant, which is what? 3 times 10 raised to the power of 8. All over wavelength. What's the wavelength given in the question? 10 raised to the power of what? Minus 10. So what do we do? Remember I told you before, multiply this by this first, so that you have 6.6 times 3. That will give us 19.8. So you have 19.8. You take 1 over 10. 10 raised to the power of minus 34, you add it with what? 8. But you minus from here because you have division here. So you have minus 10. Remember, minus will give us what? Plus. So we have 19.8 times 10 minus 34 plus 8 plus 10. So what do we have? Minus 34 plus 8 plus 10 will give us minus 16. So 19.8 times 10 raised to power minus 16. To put in standard form properly, we have to take it here. And when you do that, you add 1 here. So you have 1.98 times 10 raised to the power of what? Minus 15 what? Joules. This is the energy of the photon, or 2.0 times 10 raised to the power of what? Minus 15. So we have come to the end of today's video lesson. If today is your first time for coming across the H2O channel, please do well to subscribe to this channel and also help us to share this video. Thank you very much. I'll see you in our next video.